Hello everyone, welcome to my CCNA class. Today we're going to discuss about network fundamentals. So let's get started. In this section, we're going to discuss network fundamentals. Network fundamentals overview. Part of that, we're going to discuss networking model, TCP, IP, and OSI models, encapsulations, protocol data unit, layers interactions, device and protocol referencing. First topics, networking model. What is a networking model? Networking model tell us how to build a network, how to troubleshoot a network, and how to work around each of the layers in our network. We have two kind of networking model, OSI and TCP/IP. OSI stands for Open System Interconnections by ISO, International Organizations for Standardizations. ISO is one of the organizations who look after this OSI standard. And we have Transport Control Protocol, Internet Protocol by Department of Defense. This networking model is managed by Department of Defense, which is United States, their Defense Department. Now, history leading to TCP/IP. That means majority of the businesses, they're actually using TCP/IP networking model. Now, we're going to discuss in details about this networking model. Let's have a look bit of comparison with TCP/IP versus OSI model. What is OSI layer? Part of our OSI layer, we have 7 different layers. First layer, which is called layer 1. Then we have layer 2, then layer 3, layer 4, which is transport layer, layer 5, session layer, layer 6, presentation layer, then application layer. Part of OSI layer, we have these 7 different layers. Each of the layers, they actually related with our each of the networking terms. We're going to have a look in these things in details. And part of TCP/IP layer, we have physical layer, data link layer, network layer, transport layer, and you can see these 3 layers has been merged to application layer. They're actually very similar, but only difference TCP/IP layer, we have application layer, which is basically it's combined these 3 layers together, and we can say this is application layer. So you can say OSI layer, we have 7 different layers, and part of TCP/IP, we have 5 different layers. And you can see that we started this layer from bottom to top. There's a reason behind that, but we're going to discuss these things in details. So how OSI layer related with network? Let's have a look with one example. In this example, we can see we have one switch and PC1 and PC2. If you'd like to build a small network, at a minimum, we need a PC and a switch. Let's say, for example, these two PC, they want to communicate. Like PC1 want to communicate with PC2. So for that, we need a switch. So at first, we need to connect this PC to our switch. Let's say we connect PC1 with our switch and then PC2 with our switch. After that, we do some basic configurations. Let's say, for example, we set up some IP address. And after that, if we communicate, if you want to communicate from PC1 to PC2, switch will actually do the data transfer. So that's a very basic things with networking. This is a very small network. But over the time, let's say if your network grows, we can add more PCs in here, more servers in here. But at a minimum, you need a switch. Now, we're going to explain this network with our OSI model. Now, let's have a look at our OSI model. Part of our OSI layer, our first layer is layer 1, which is physical layer. Physical layer main job is to do the bit transmission, provide signals, and also do cabling. Any network we build, we must have some physical connectivity. Let's say in this example, we have PC1 and PC2. They connected with physical connections. This is Ethernet connections, Ethernet cable connections, or we can say network cable over there. At first, we need to have physical layer. Let's say, for example, we want to add more servers, we want to add more other devices, access point, and any other devices we want to add in here. We need to have switch. So we need to have switch, and also we need to have physical layer connectivity. So this is the first requirements for any network we want to build. We must have to have physical connectivity. Once we have a physical connectivity, then we can turn on the power. And once we have the power, they will have some signals. Once you have the signals, then this PC, they will start to send the bits. Bits means ones and zero, ones and zero. In this way, it will start to communicate from one locations to another locations. Now our second layer, this is called layer 2. Layer 2, we call it data link layer. Data link layer, it's maintain Ethernet standard. And also one of the important things we have called MAC address. It does many other things, but at a minimum part of the network fundamentals, you need to know that it has layer 2, it maintains Ethernet standard, and also it works with MAC address. What is MAC address? Every electronic device, they will have their MAC address. For example, this PC1 will have one MAC address, PC2 will have MAC address. So this MAC address is individual or unique identification number for a device. Let's say, for example, in a company, you have 50 computers. So 50 computers will have 50 different MAC address. MAC address is basically individual identification number. Let's say this PC will have unique MAC address. This PC2 will have unique MAC address. Moreover, switch, each port, they will have their MAC address as well. So this MAC address, they are actually sitting on our layer 2, which is called data link layer. Next layer, which is layer 3, network layer. Part of network layer, we have IP addressing, IPv4 and IPv6, address resolution protocol, which is we call it ARP, ICMP, which is Internet Control Messaging Protocol, and there are many other protocols. They are actually sitting on layer 3. But at a minimum, we need to remember that IP addressing, they are part of layer 3. IPv4, IPv6 address configurations, they are part of layer 3. Now, what is IP address? IP address is the location informations. Location information means, let's say, this PC1 and PC2, they are connected with this switch. So PC1 and PC2, they will get the IP address from this network. So that means whatever network your device is connected, it will get IP address from there. Let's say you go to office and you take your laptop over there and you connect with your office network. So you'll get IP address from the office network. So that means whatever network you connect, you'll get IP address from there. Let's say if you connect with your home network, you'll get IP address from your home network. If you take your laptop to any office, or if you go for traveling, go to airport and another city or another country, so another place, and if you connect any network over there, you'll get IP address from there. But wherever you go, your device MAC address will not change. So MAC address will be connected with your network interface card. So if you have desktop will have Ethernet port and MAC address will be there. If you have laptop will have a wireless network interface card, and your MAC address will be bind with that wireless network interface card. So wherever you go, your MAC address will not change. So important things in here, IP address can change based on your locations, based on your connectivity, but MAC address will never change. It will always remain same. So next layer, we have layer 4, which is transport layer. Part of transport layer, we have TCP, UDP, and port number. TCP, UDP stands for transport control protocol or transmission control protocol, user datagram protocol. They are transmission control protocol. Their main job is to transport information from source to destinations. For example, we have PC1. From PC1, we sending informations to PC2. So TCP job will be take the bits from PC1 and send the bits to PC2. So basically bits means ones and zero, ones and zero, ones and zero, like that. So TCP main job is to transport the information from source to destinations, and some areas we are using TCP, some areas we are using UDP. For example, in order to send data and documentations, we are using TCP. In order to have live communications, we are using UDP protocol. So TCP, UDP, they are part of transport layer. And also we have port number. What is a port number? Port number, this is, we call it logical port number. Always remember, there's a physical port number, there's a logical port number. Physical port number means, let's say our switch in here, it has physical port number. But what is a logical port number? Logical port number means they are not connected with any physical things. They are actually related with applications. For example, HTTPS port number is 443, HTTP port number is 80, FTP, which is file transfer protocol, port number is 21, and so on. And there are many other port number as well. But TCP, UDP, and port number, they are actually related with our transport layer. After that, we have layer 5. Layer 5 is session layer. Any communications we do, we have a session. Let's say from our PC, we communicate with some web server. So from PC to web server, we log in. After that, we perform some task in our web server. It could be 1 minute, it could be 5 minutes or 10 minutes, but in the backend, it will have a session. In an example, let's say when you log into any netbank, our session will start from that time. And maybe we use that netbank service for 5 minutes or 10 minutes. After that, we log out. So our session will be ended. So session layer main job is to keep track of communication session. After that, next layer we have layer 6, which is presentation layer. Presentation layer main job is to produce the file format, such as MP3, PDF, doc, etc. Presentation layer main job is to produce the file format from the bits. Let's say all the way from layer 1 to layer 2 and all the way when your bits will go to end user site, the presentation layer will produce some file format. So we can read those file format. Next layer, which is layer 7. Layer 7 is application layer. Application layer, part of that, we have many different kind of protocol. Let's say HTTP, which is port number 80, DNS, and SNMP, SMTP, and so on. So application layer protocol actually helps end user to open that file, read that file. Now, these are the 7 different OSI layer we have, and they are related with our network model. Now, they are very important. Let's say, for example, if you'd like to build a new network, you can follow this networking model. Let's say, if you want to build any new network, you must have to have physical layer. Then you must have to have data link layer. Physical layer means all the cabling need to be done. Data link layer means you need to ensure that right cable is connected. Then network layer, let's say you need to ensure that proper IP address configurations is done. After that, we need to ensure that TCP, UDP, they can communicate from source to destinations. Make sure source TCP protocol and destinations TCP protocol, they are working properly. They are not blocked from firewall or other areas. Then in the backend, any communications you do, session will be there. Presentation layer will produce file format and application layer will be there, so user can read those file format. So all these 7 layers, they are very important. So if you send any email from PC1 to PC2, so basically email will go through all physical layer, make sure it's connected with the right device. And after that, IP address need to be there. Then proper TCP protocol should be accessible. And then you need some mail client or web browser, that is actually application layer. So this is OSI 7 different layers, and difference between OSI and TCP/IP. TCP/IP network model has 5 layers. In TCP/IP, all these 3 layers, let's say layer 5, layer 6, and layer 7, they combine to application layer. We can say this layer 5, layer 6, and layer 7, they are related with applications. So in TCP/IP networking model, we have layer 1, layer 2, layer 3, layer 4, and layer 5, 6, and 7, they actually combine to application layer. Now let's say this networking model is very important. Whether you like to build any network, whether you want to troubleshoot any network, you can actually use this networking model. For example, an end user saying that they have some problem with their computers. They do not have any internet connections. That kind of scenario, what are you going to do? What are the troubleshooting steps you're going to take? So any kind of issues, you can actually follow this network model. At first, you can say whether physical layer is okay or not. Let's say if that person saying that my internet is not working, there could be many issues related with that. But how are you going to sort out those issues? At first, you check whether physical layer is okay or not. If physical layer is okay, then you check data link layer and make sure right device is connected. But if right device is connected, then you check whether IP address issues or not. If IP address is okay, let's say there's no issues with IP address is perfect, then you check whether any port is blocked or not, any protocol having issues or not, whether firewall is blocking something or not. So if layer 1, layer 2, layer 3, and layer 4, if all of the layer is okay, then maybe that issues related with application layer. Mostly application layer cover our layer 5, 6, and 7. It could be issues any of this layer. Let's say maybe MAC address problem, or maybe IP address problem, or maybe physical layer, somebody unplugged something, that's why it's not working, or could be logically someone blocked the port. Any of these issues happen that will interrupt the internet connections. So for any troubleshooting purposes, we can actually using this OSI model. In fact, many company in the industry, they actually using this OSI model for their troubleshooting process. So this is very important. Some of the important things to remember from here, let's say switch. Switch is layer 2 device. So let's say in here, one example, we have 2960 catalyst switch. This is layer 2 switch. Layer 2 switch means they mostly work with MAC address. Some switch can do routing. We call them layer 3 switch. For example, we have Cisco 9000 series switch. They actually call layer 3 switch. Layer 3 switch means they can do routing as well. They can do switching, and also we can use some of the ports as layer 3 switch. Then let's go to router. So router is layer 3 device. Let's say Cisco 1000 series router. So they actually layer 3 device. Layer 3 device means they can do routing. Again, switch is layer 2 device. That means switch main job is to forward the frames. So if you want to send something, you can send that one to switch, and switch will forward to destinations. That's like local environment switch is working in this way. But router, layer 3 device. Router can do routing. Router actually can take the packets from one subnet to another subnet. So layer 3 switch can do routing, and router also they can do routing. So many people ask the questions, why we using a router, and what is the difference between layer 3 switch and router? Because both they can do the routing. So why we should using router? We can use router. Router is a dedicated device which can do routing, and it has many different features, many different advanced features. Let's say some security features, wide area network features. It has capability, performance, functionality. It has more features and functionalities than layer 3 switch in many cases. And on the other hand, layer 3 switch can do switching. Also, it can do routing. So many contexts, layer 3 switch will be very useful. In fact, many businesses, especially small to medium sized businesses, they're using layer 3 switch for their routing as well. So it's really based on the scenarios, individual scenarios, we can use either layer 3 switch or router. We can say for internal routing environment, layer 3 switch will be ideal. And for any external communications, for example, internet connections or wide area network, we can use router. What is IP address? So IP address we write down in this way, in decimal format, 192.168.10.1. Decimal number is basically all these 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. They are all decimal number. So we need to remember here, router actually deal with IP address. Mostly router work with IP address. In general, we need to remember this one. Let's say switch deal with MAC address. This is one of the MAC address we have. MAC address written in hexadecimal format. And computer actually understand binary. So whether you write down any decimal or any hexadecimal format, but eventually computer will understand that communications in a binary way. Binary means all ones and zero, those bits. So in general, we need to remember that router work with IP address, router deal with IP address, switch deal with MAC address. Important things to remember: how to check IP address, how to check MAC address, how to check DHCP and DNS address from our computers. That's one of the important part. For Windows PC, we can use ipconfig/all. For Mac OS, we can do ifconfig. We need to go to terminal and then we can apply this command. Let's say Windows PC, we can go to command prompt, and then after that we can apply ipconfig/all. Let's say this is a wireless LAN adapter in my computers, and from that I can see my MAC address informations. I can see my IP address informations, which is 192.168.1.115, and I can see my subnet mask. I can see the default gateway, DHCP servers, and also DNS servers. So DNS servers and DHCP servers, IP address, they are same. So that means DNS and DHCP actually pointing to my router. So this sort of command we need to remember. Now encapsulation means process of putting headers around our data. Data means, let's say, for example, I want to send email to someone. So that's my data. Like I have some email and email contains something. I want to send that email from my PC to someone else. So during that time, with my email or with my data, all the layer header will be added. For example, TCP header will be added. That means TCP informations, IP informations will be there. Data link means MAC address informations will be there, and eventually those informations will transmit as like a bits. So you have a data. Data means this is our email, and when you're sending that email, with that, all this layer header will be added. And also we can see this layer 2, which is data link layer. We have the trailer. These sections we have frame check sequence, basically FCS. FCS actually does frame check sequence. But at a minimum, at this stage, you need to remember that when you're sending our data, when you're sending anything from your device to another device, so basically all the OSI layer header will be added. Only layer 2 we have trailer. Trailer contain FCS, which is called frame check sequence. It will ensure that frame is error free. So that encapsulation means all the headers and trailers will be around our data. Now this data, in each layer, we have a different name. For example, end user saying, I am unable to send my data, but end user referring to some data. Data could be anything, could be some files, could be some email. So they refer to that one data. So that data in different OSI layer, we have a different name. For example, when data is traveling in physical layer, we call it bits. When it is traveling to data link layer, we call it frame. When it is network layer, we call it packets. When it is transport layer, we call it segments. Segment means, let's say, TCP segment, UDP segment, like that. But session, presentations, and applications, all these three layers, we can call them all together application layer. Application layer, we call it data. End user, when they want to send some data, they can say, I can't send my data, I can't send my email. But when you analyze that one with our network model, that time we analyze in this way. In physical layer, we call it bits. Bits means all ones and zero. Data link layer ensure that we have proper MAC address and frame is built properly, and packets is layer 3. So what is a packet? So packet, maybe we familiar. See, many different times we do ping, right? When you do ping, we actually ping, let's say ping google.com.au. And then we see from my PC to Google, I can communicate or not. Protocol data unit. Protocol data unit means, let's say when you're sending our data, around our data, layer header and layer trailer will be added. LH means layer header. LT means layer trailer. So that means when I'm sending my email, with my email, application layer protocol will be added, presentation informations will be there, session informations will be there, TCP, UDP protocol informations will be there, port number will be there, IP address will be there, MAC address will be there. Like what is my source MAC, what is my source IP, what is my protocol, everything will be associated with data. And after that, this data will travel to destinations. And only layer 2, we have the trailer. So trailer contain frame check sequence. So this is one of the mechanism. This mechanism will ensure that in layer 2, our frame is error free. Now, overall, this is the summary. Let's say physical layer, we talked about Ethernet standard, cabling. So protocols and specifications, we using RJ45 cable. So cable is part of our layer 1. Over there, we using RJ45 port and it's maintain Ethernet standard. And physical layer device, we have hub. Hub is one of the old device similar to switch, but we are not using much hub these days. Hub is layer 1 device because it doesn't have all the smart capabilities. That's why we call it hub. Hub is similar to kind of connector. Then we have repeater. Then we have cables. All these components, they're part of our layer 1. Then we go to layer 2. Part of layer 2, we have Ethernet standard, and part of that we have HDLC, high level data link control protocol, and there is a PPP point-to-point protocol. There are many other steps we have, but at a minimum, we have these steps. At a minimum, we have Ethernet and HDLC protocol. They are part of layer 2. HDLC is wide area network protocol. In terms of device, LAN switch, wireless access point, cable modem, DSL modem, all of them, they are part of layer 2. Switch, we talked about wireless access point. Their main job is to provide the wireless signals. So large organizations, we are using access point. Access point can provide the wireless signals to many devices. Cable modem, DSL modem, NBN modem, they are kind of layer 2. They actually transmit the informations in layer 2 level. Network layer 3, mostly protocol is IP and router is layer 3 device. Transport layer, which is layer 4, TCP, UDP protocol, they are part of transport layer. And host and firewall, they actually part of layer 4. So switch is a layer 2 device. Wireless access point, that will be also part of layer 2. Router is layer 3 device. Host and firewall, that will be part of transport layer. Host and firewall means we're talking about more on hardware device. Let's say Cisco ASA is a hardware firewall. So this is part of our layer 4. And host means any servers, any PC, we call them host. And then we have application, presentations, and session layer. They are 5 to 7. Part of that, we have some protocol, telnet, HTTP, FTP, SMTP, POP3, VoIP, SNMP. All these protocols, they are part of our application layer. And devices, we have host and firewall. Host means any individual host, let's say any PC, Windows PC, or it could be any Windows servers. And firewalls, it could be Cisco ASA firewall or Fortinet gateway. All of these devices, they are part of applications, presentations, and session layer. Overall, this is the summary of our network fundamentals. I hope this information was useful for you, and thank you for watching.